This is a lecture video for section 6.2, video 2. Here I'm going to show you one solving trigonometry equation problem using the zero factor property. So now we're going to talking about factoring problems. So the example 2 I have is I want to solve the trigonometry equation cosine of theta times cotangent of theta equal to negative cosine of theta. Here, I want the answer to be over the interval 0 to 360 degrees. So, zero factor property. So just quick reminder, zero factor property says if I have two expressions, a times b equal to 0, then either a equal to 0 or b equal to 0. Here, a and b can be number, can be expression, can be like x plus 3 form. So here, if I want to use the zero factor property, I need to have a 0. So first I'm going to adding the cosine theta on both sides. So I end up with cosine of theta times cotangent of theta plus cosine of theta equals to 1. And then in order to use the zero factor property, I need to have a times b. So I'm going to factor out the common factor here, which is cosine theta. Then the first term will only have cotangent of theta, the second term only have 1. So I end up with cosine of theta times cotangent of theta plus 1 equal to 0. According to the zero factor property, that cosine of theta equal to 0 or cotangent of theta plus 1 equal to 0. So cotangent of theta plus 1 equal to 0 tells me cotangent of theta equals to negative 1. Cosine theta equal to 0 tells me theta is going to either equal to 90 or 270. Either 90 or 270 in the unit circle. Cotangent of theta equal to negative 1 tells me theta is going to be in the family of pi over 45 degree, but cotangent is negative. That means in quadrant 2 or quadrant 4. In quadrant 2 with 45 degrees, so 180 minus 45 degree, this is in quadrant 2. Or in quadrant 4, which is 360 minus 45 degree, that's in quadrant 4. So calculating them, I got 135 and 315. So together, my answer is going to be theta can be 90 degree, or just writing them in orders, 135 degree, or 270 degree, or 315 degree. So I have 4 answers here. So just do one more example using the zero factor property. So this one, example 3, we want to solve the trigonometry equation cosine squared theta minus sine squared theta equal to 0. We want to solve it over the interval of 0 to 360. So the equation cosine squared theta minus sine squared theta, this is a special form that a squared minus b squared equal to 0. We can factor it into a minus b times a plus b squared equal to 0. So that means I can factor cosine squared theta minus sine squared into cosine theta minus sine theta times cosine theta plus sine theta equal to 0. Using the zero factor property, I will have cosine of theta minus sine of theta equal to 0, or cosine of theta plus sine of theta equal to 0. The first one tells me cosine of theta equals to sine of theta. The second one tells me cosine of theta is equal to negative sine of theta. Okay, so from those two equations, we do not have any numbers. We can say, cosine of theta equals to 1/2, so theta equals to pi over 3 or such and such. We only have relationship. However, throughout the entire unit circle, the only situations cosine theta equal to sine theta are thetas have a reference angle of pi over 4. So pi over 4, and then cosine theta equals to sine theta. That means theta is in quadrant 1 or quadrant 3. So reference angle 45 degree in quadrant 1 or quadrant 3. Quadrant 1 both are positive, quadrant 3 both are negative. On the other hand, cosine theta equal to negative sine theta. That means they have the same value but different sign. Then the only situation we will have it when they have a reference angle of 45 degrees still, but in quadrant 2, when sine is positive, cosine is negative, or quadrant 4, when cosine is positive, sine is negative. So combining both answers, I know here my theta is going to be all the numbers, all the angles with reference angle of 45 in the unit circle. So for all 4 quadrants. So start from 45 degree to the second quadrant, 135 degree, to quadrant 3, 225, and quadrant 4, 315.